Okay, so the next job, now that we know what the algebraic view of a vector is to go between the two, right? So if I give you a geometric representation of a vector, how do you give me the algebraic one, and vice versa? So just to remind you, right, a geometric view means the vector is given by its magnitude and the direction. So we talked about how do we define that. For example, this vector, I can say that it has a magnitude of 5 and it has a direction that is 30 degrees above the positive x-axis, give all three pieces of information. So that's a geometric view. And then we can have the algebraic view, which you just need to tell me the x and y components, right? So here, as you can see, we'll focus first on vectors with 2 dimensions, right? So we'll focus on 2-dimensional vectors. And don't worry, we'll actually not touch 3-dimensional vectors in this course. It's much more complicated, but we'll focus on 2 dimensions so that we can actually draw it on the whiteboard, right? And you see that there's the same amount of information you get. So one view does not sort of have less information. Here you need to give 2 pieces of information, the magnitude and the direction. And here you need to give 2 pieces of information, how much x and how much y. For example, we can have A is, for example, 2, 3. And what that means is you can immediately draw it out, right? 1, 2, and 1, 2, 3. So you go 2 units. So remember that is just a shorthand, a lazy way to write 2i plus 3j. So 2 i's mean you go this way and 3 units in the y direction. So you can immediately draw this out. So you can tell that's A, right? So for example, if I give you this, can you give me the magnitude and the direction? Or if I tell you, let's call this B, right? If I tell you the magnitude and the direction of B, can you write down the algebraic way? So in this first part, let's address, let's go this way first. It's actually easier. Okay. So if I give you that, how do you give me the magnitude and direction? The tip is always start with a sketch. Okay. Okay. This is the biggest advice I can give you, right? So if someone gives you just the component forms, I should say that component form or the column form, first always sketch it out, just like what I did, right? Now it's pretty easy, right? I know that. Let's draw it down here and here. And now you need to remember your trigonometry, all right? So if I have 2 units here, so this length over here is 2, right? And 3 units upwards, right? This length is 3. How do I find the length? So from trigonometry, right? So if you remember the Pythagoras theorem, then it will tell you the hypotenuse, right? The longest side, which is called the hypotenuse, is basically the sum of squares of the other 2 sides, right? So the magnitude of A, remember this notation, it's the magnitude of A is, or the square of that, right? The square of that is 2 square plus 3 square, like that. Okay, so what's 2 square plus 3 square? Well, that's 4 plus 9, that's 13, right? So the magnitude square, right? So just to be clear, I'll break it out, right? So this is 2, this is 3. We want to find what that is, right? So 2 square plus 3 squares is equals to question mark square. So what is the magnitude of A? Well, just take a square root, right? It's 13. Remember when you take square roots, normally in math, there is always a plus and minus sign, but now you need to use a little bit of common sense and understand that that cannot be negative. It's a magnitude, it's the length, right? You cannot have -1 meter of length. That just does not make sense. So you reject that, and the sensible answer is square root of 13. So you can plug in the calculator, which would be 4 point something, sorry, 3 point something like that. Okay, whatever the units is. So remember to put in whatever the correct units is. All right, that's finding the magnitude. Remember, what is my goal? My goal is, given this, we want to try to find the magnitude and the direction. How about the direction? Now, this is a little bit more tricky, right? So you need to remember your other trigonometry. Let me draw this out in a clearer way, right? So that's the vector. It's 2 units this way, 3 units this way, right? On a grid like this. So let's calculate this angle, right? So remember your sine, cosine, and tangents, right? This is opposite over adjacent, right? So that will be tangent. So tangent theta is 3 over 2. Okay, so what is theta? Well, theta is arctangent of 3 over 2. And all you have to do is plug that in a calculator, right? And make sure, here's a tip, make sure your calculator is set in degrees and not radians or gradients. So make sure of that. And you plug in the calculator and you can verify it right now to make sure I got the right number. And I think I got 56.3, and it's roughly 56.3 degrees. That's rounded to 1 decimal place most of the time. These are fine. Okay. Now, is that the final answer? Well, this is good, right? That's the magnitude. But don't just leave it like this. Remember, when you give a direction of a vector, you need 3 pieces of information. So I should say the complete answer is 56.3 degrees upwards of the positive x-axis. Of the positive x-axis. So you have 3 pieces, count what angle, which way, and from where, like that. In case you're wondering, the 3 dots over here is it's a lazy way of writing therefore. So if you're taking notes, this is very useful. Okay. So this is the mathematical symbol of therefore. Mathematicians are very lazy animals. We invent symbols for everything. If you've ever seen a mathematical textbook or a mathematical paper that has a bunch of Martian symbols, they're not Martian. They're basically just everything directly translates to a word or a phrase. And if you actually translate everything back, even if grammatically, it makes sense. It's actually grammatically full sentences. It's just mathematicians are lazy and invent symbols for anything. I won't use too much crazy symbols, but every now and then these things are handy. All right, so that's an example of how you go from algebraic to geometric. Let me do one more example. Yeah, let's do that before I show you the other way as well. Okay. So let's this time have another one. For example, this is vector, I'll call it vector C, which is minus 3i plus 2j, right? So this is in the algebraic view. I'm giving this vector C in terms of its components, its x component and its y components. So personally, I like to write this in column form, as I said, right? So I'll immediately write it like this when I'm given a component form, and it's a little bit easier to visualize, right? So the first step, remember, sketch it out. Okay, so x, y, where the C points, right? So minus 3 in the x direction, right? So it will be this way, 1, 2, 3, and plus 2, 1, 2. So it will be going this way, 3 units, negative 3 units on the x, and then positive 2 units this way, right? So let's actually draw this out. If you have a grid, that's even better. Okay, so this is my arrow. This is C. Okay, so what is the direction? What is the magnitude and the direction, right? So that's the question. Well, if this is 3, this is 2, again, we use Pythagoras theorem to find magnitude of C. So the magnitude of C square would be 2 square plus 3 square. This incidentally is the exact same numbers, so I can just do that, right? So that gives me 13, and therefore this is positive square root of 13 units. However, so it's same as the A as we done before. However, the direction is different. So it's a different vector, right? The magnitude is the same. It does not make it the same vector. It also has directions. So now we can pick another angle. Let's pick this angle, right? So, so we can write tangent theta. And notice whenever I write a new symbol here, I always write it on my diagram. So people who are reading your work can actually refer to that and see what your theta is. If you do not have a theta there, people reading your work, i.e. us grading your exams, will not know what your theta is because you could have called the other one theta, right? So we don't know if you do it correct or not, and you might not get the points. So remember to do that. To whenever you introduce a new symbol, you always have that in your diagram somewhere, right? Okay, so opposite of adjacent, right? So it's 2 over 3 like this. right? So what's theta? So you want to make that a subject or isolate that. So make that arctangent or tangent inverse, 2/3, right? And if you plug that in a calculator, that would just give you around 38, right? Sorry, 34. So that would give you around 34 degrees like that. And 33.7, but that'll work. I'll use one more decimal place. Remember, that's not the final answer. Remember, you always want to give 3 pieces of information. So in this case, if this is 33.7 degrees, we need to say that is, let's say, 33.7 degrees upwards from the negative x-axis. Right, so you have all 3 pieces of information, and that's all right. So that's the general procedure. Basically, use Pythagorean theorem and use your tangents, and that's how you go from algebra to geometric view. Now let's look at the other way around as well.